Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahrim Biswahimi. I'm from J4AM 1104H, and today I will talk about Lab MEM 360 number 2, which is milling test. Okay, for this project, the material that we use is aluminium alloy, and the stock size for this material is 200 mm in length times with 150 mm in width and 43 mm in height. Okay, for the for the step 1 and 2 is already given, and after that for the step 3 is we use the rough mill, and for this step I starting with everything is rough mill, and after I done with rough mill, then I will start with the counter mill. So as you see here, the number 3 is the number 3 is this place, and number 4 is the circle place, and number 5 is the smaller circle. And then I start, after I done with this place, I continue with this place, and then after I done, I do the counter mill at this place for the number 7, and the outer space for the rectangular shape here for number 7, for the number 8, and then I continue with the inner place for the number 9, and then and then finishing for number 10 at the circle, a bigger circle and a smaller circle for 10 and 11. After I done with this, after I done with this, I do step number 12, which is this shape here. Okay, next I will talk about step 3, which is a rough mill rectangular pocket. And for this step I will do is continuous for all the second step, but for the second step we get a outer shape, and for number 3 we get the inner shape. Okay, for the cutting tool to this step is mu and mil, and the description for the cutting tool is 50-S32-10-5T. The number of insert or fluid for this cutting tool is 5, and the size DC dimension is 50, and the LF and LH is 120 and 40. Okay, the reason I choose this cutting tool because as we can see here, the outer length for this shape is 120, but for the inner here we didn't know, so we use a calculation, which is we minus with the thickness for this shape, which is 10. So 120 we minus with 10, we get 110. So to get the DC for the cutting tool for this place, we divide the 110 with number 2 with 2. So after we divide, we get we get a 55. So from the appendix we didn't have any cutting tool with the 50 for the 55 for the DC, so we choose the smaller one, which is 50. Okay, so that's why the DC for this cutting tool is 50. Alright, and as we know, every for a cutting process, the cutter material is carbide. Only drill is using HSS, and the cutting speed as given in the software is 274 meter per minute. And the end mill diameter, we take the DC here, which is 50, And for the machine max, we can choose between 5,000 to 6,000, but I choose 6,000 for make my calculation easier. And then the cutting edge of flute, also we take from the number of insert of flute, which is number 5. And then after we done with the calculation, we got the spindle speed, which is 1740 millimeter over flute. And then for the chip flute, we get a 0.4 millimeter over flute. I'm sorry, for the spindle speed, we get 1740 RPM, which is the revolution per minute. And the chip flute is 0.4 millimeter per flute. And lastly, and the feed rate, here we get 3489 millimeter per minute. Okay, after we done, we need to find the estimated time, which is we need to divide length of cut, we divide with feet. So as we already done the calculation before, the length for this place is 110 millimeter. We divide with 3489 millimeter per minute for the feed rate. So after we divide with the calculator, we get a 0.0032 minute. Okay, and as you can see here is a illustration for the step 3. As you can see, this is the given, which is the outer shape, and then we done with the inner shape. Okay, that's all from me. I hope you guys understand with this explanation, and thank you from me, and goodbye.